All, how are you? This is PAL discussion week 13. If you have done your PAL exercise, so you can continue to watch this video. If you haven't, please stay tuned. After finish your PAL week 13, then only proceed with this video checking. Good morning. This is a short video about PAL week 13. So first of all, if we look at the right hand side is the question and the left hand side is the answer. Before we look at the answer, we need to discuss the question. So look at question number 1. Look at my cursor. In the offshore-based oil during operation, methane gas CH4 was found at the bottom of the sea at 480 degrees Celsius and pressure 12.8 atm. So the information given is over here is methane. We'll discuss about methane, and then this is the temperature, and then this is the pressure. Make sure that later involve the calculation, if must change to Kelvin plus 273. So the first question, calculate the volume. Okay, and then with the volume of the, this volume in liter. And then pressure 1 atm, temperature 22 degrees Celsius. So over here, you have to know, actually this question is combined between pressure, volume, and temperature. If you know, right, pressure and volume is about Boyle's law, volume and temperature is about Charles' law. So we are applying the P1 V1 over T1 equal to P2 V2 over T2. So we just substitute. So the first set is 480 plus 273, 12.8 atm, and then the volume we're not sure. So this is the V1 we need to find out. And then for the V2, 1.8 times 10 to the power 3 liter, 1 atm for pressure, and then temperature, remember, 22 plus 373. So write out the formula, substitution, and then you success to find the V1, which is 359 liter. Okay, for part B, determine the mass of the gas being transferred. So this one we are going to apply PV equal to nRT. 1A2. Determine the mass of the gas being transferred. Okay, so the question now want to find mass of the gas. So the gas is CH4, methane. The molar mass is 16. 4 plus 12 equal to 16. Okay, as we know, right, mass of gas, we can find the mass of gas through PV equal to nRT because N equal to mass over molar mass. So you substitute this formula into PV equal to nRT, then you will get PV equal to mass RT over molar mass. Okay, if you still remember, right, for previous PAL exercise, we are finding the molar mass. But for this question, we need to find mass. But the concept is still the same. Okay, now you substitute P is 1 atm, V is 1.8 times 10 to the power 3 liter, and then molar mass is 16 gram per mole over R 0.08206 liter atm per mole per Kelvin. Okay, over here per Kelvin, okay, and then times 295 Kelvin, so equal to 1189.7 grams. So this is the mass of methane. Okay, clear? Please do a correction over this unit, liter atm per mole per Kelvin. So per Kelvin, Kelvin cancel off. Here per mole, mole cancel off. atm, atm cancel off. Liter, liter cancel off. So the remaining unit is gram. Okay, part B, differentiate between amorphous and crystalline solid. Okay, for this one, right, actually you can answer in table. For example, the first one is structure. Crystalline solid, okay, the structure is arranged orderly. For amorphous, the arrangement is not orderly, or the structure is not ordered. Then for crystalline solid, it forms cold slowly, but for amorphous, form cold rapidly. Okay, and then melt rapidly for crystalline solid and melt slowly for amorphous solid. So the details you can check again through your lecture notes. Okay, now for C, about phase diagram. So phase diagram, right, as I mentioned before, there are 5 to 6 points you need to remember. First of all, write down the title. So this is phase diagram for carbon dioxide. Okay, next you have to label the y-axis for pressure in atm. and then x-axis temperature. Since the question given in degrees Celsius, right, actually no need to change, it doesn't matter. You can remain it as degrees Celsius. Here, if you change to Kelvin also can, no problem. Okay, so up to you if the question didn't mention anything. Okay, so next you have to check for the point, triple point at 5 atm, negative 57 degrees Celsius or 216 Kelvin. And then 73 atm is the critical point. Okay, the temperature is 31 degrees Celsius or 304 Kelvin. So must label T and mention triple point because T is nothing. T just an alphabet. So we will T triple point. Same for here, C critical point. And then this is carbon dioxide, right? Make sure the shape is positive slope. So the TB slope is positive. Then, okay, 1 atm, and then this temperature is not given by the question. Actually, right, if possible, you try to remember a bit the point for the 1 atm, okay? And then, okay, so you have to draw the shape. Okay, here is solid phase, liquid phase, vapor phase. Okay, 1 mark for the label phase. For your syllabus, phase diagram just involve carbon dioxide and H2O. So you have to have a look for these two phase diagram. Now we proceed with question number 2. Figure 1 shows two connecting vessels containing different gases. Okay, the first one is hydrogen, 1 liter 0.5 mole. Another one is 3 liter 0.25 mole for carbon dioxide. When the valve between the vessel is open, so mean over here the valve open, so the gas are allowed to mix. Now what is the difference? What is the changes? So the changes is just now here 1 liter, here 3 liter. When it open, right, when it combine is equal to 4 liter. So ignoring the volume taken by the valve, okay, calculating the partial pressure of each gas and the final pressure of the mixture. So this case, we are going to apply PV equal to nRT as well. Okay, so nRT over V. Why PV? Initially it's PV equal to nRT. Now the question asks about partial pressure. That's why nRT over V. In this case, the change is the V. V now is become 4. So 0. This is partial pressure for hydrogen. The mole still the same. R constant. And then the temperature 25 degrees Celsius. Remember, must change to Kelvin. Okay, again. Start from chapter 5, chapter 6, chapter 7. All the temperature must in Kelvin if involving calculation. Okay, same for partial pressure of CO2. Okay, 0.25 mole RT over 4. So this is the partial pressure of carbon dioxide. Then you join together, sum up to get sum both of the partial pressure, total up the both partial pressure, then you get 4.59 atm. So this is the final pressure of the mixture. Okay. Next question. Describe the phase change when water at negative 10 degrees Celsius is heated at a constant pressure of 1 atm to 115 degrees Celsius. Okay, meaning that this one phase diagram is not given but asks you to describe. Never mind, let's check the phase diagram from our lecture notes. Okay, this is the phase diagram for water. Okay, so you can check, right? Actually, at constant pressure, if you're across, right, based on the negative 10 until 115 degrees Celsius, actually it's across fill point. Okay, so across solid, and then over here is solid and liquid at equilibrium. Here liquid, and then here is liquid and vapor at equilibrium, and then vapor. So there's a term, okay, for the condition where pressure constant, temperature increase. Do you still remember what is the term? Okay, we try to recap a bit. Okay, so based on the question, the condition at constant pressure, temperature increase, we call it as isobaric. And then for temperature constant, pressure increase, we call it as isothermal. Okay, you must remember the term for these two conditions so that you can answer the question while they are using the term isothermal or isobaric. Okay, so let's check the answer. Okay, so you have to describe one by one. Okay, as starting, negative 10 degrees Celsius and 1 atm, water is in the form of ice, means solid phase. When heated, the temperature of the ice increase. So what happened? The water molecule in the start to vibrate faster. Okay, here you have to explain a bit about the kinetic. Okay, kinetic energy. So at 0 degrees Celsius, the ice starts to melt and form liquid. But before it form liquid, right? Okay, both solid and liquid water exit in equilibrium. During melting, the temperature remains constant as the heat energy provided is used to overcome the attractive forces between molecules. So this is the process that happens for solid and liquid at equilibrium. Same for here, also the same. Okay, next is ice continue melted and then become liquid. Now liquid, okay, at 100 degrees Celsius will um, change to vapor form, water vapor form. So before the liquid change to vapor form, the liquid water and the water vapor exist in equilibrium as well. During the boiling, the temperature remains constant as the heat energy provided is used to overcome the attractive forces between the molecules. So exactly the same. Okay. So when heated further, the temperature of water vapor increase. So you have to explain part by part. Here. Okay. That's all for how week 13. Okay. So you can jot down the final answer for week 15. So the first one, okay, 0.3 mole for NO, oxygen 0.15 mole. Okay, B, KC 2.07, KC is 0.0675, KP is 2.07, and then C is shift to the right. Then question number 2, write down the KC expression and then calculation. So the concentration of hydrogen is 0.0375 molar. Water is 0.0143 molar, and then for C is shift to the right. Here, so jot down the answer, try to do how week 15. Get ready for it. See you all next week in the next video. Bye.